Welcome, everyone. I'm Shah, and this is the Data Entrepreneurs Podcast. Super excited today because Hamel is here, and we're going to talk about how to build AI apps that don't suck using Evals. Hamel, thank you so much for joining me today.
Happy to be here.
And just to hype this up a little bit, I had the opportunity to take Hamel's Evals course back in May, like when they first launched it, and I would say like this fundamentally shifted the way I approached AI engineering. Before it was kind of almost felt like I was praying to the AI gods that I was hoping that GPT would do what I was trying to get it to do, through writing prompts, but after the course, I kind of have this more like systematic framework for evaluating LLM systems, improving prompts systematically, and actually making AI engineering feeling like AI engineering. So that's going to be what we're going to dive into today. So before kind of getting into the systematic frameworks and all these kinds of advanced techniques, um, let's just start with a basic question: like, what is an AI eval, and why should we care about them?
Yeah, an AI eval is a way to measure your AI product to see if it's doing the things you want. So um, it's the system or the processes that you can use to measure stochastic systems, particularly the ones we're talking about are AI systems using LLMs nowadays. But it's really applying a lot of machine learning and data science principles to AI products. And when we talk about evals and the kinds of things we teach, we narrow the focus on what machine learning data science principles you need to know to build AI apps. So not the whole breadth of all of data science and machine learning, um, just the things you need. And we don't even use a lot of the terminology of data science and machine learning. We talk about it in plain language most of the time. We do introduce some terms, but it's really important to have some of those skills when you're building an AI system. Otherwise, it's really hard for you to make progress or reason about if you're like measuring anything or reasoning about if you're doing better.
So an eval is basically measuring if the AI app, the AI product is doing what you want it to do. And this isn't just specific or unique to large language models. Like this is a set of tools and techniques that humans have been using for a while, whether it's in data science or just generally measuring any system that is unpredictable or random, stochastic.
Yeah, you have to tweak it a little bit for LLMs.
Okay.
You know, kind of have a little bit different tactics, but it generalizes really well a lot of the techniques from machine learning, data science. So that's what we teach is okay, how do you do that?
Okay, perfect. And I mean, that's exactly the question I was going to ask next. So, like, we have a lot of tools that we can pull from, but maybe we have to tweak them a bit for LLMs. But so, what does that actually look like when I want to build some LLM system? I've got a killer AI product idea. Like, how do I use evals to, well, one, how do I actually create that eval to see if it's actually doing what I want it to do?
Yeah. So first of all, you don't need evals right away. It's very reasonable, and you should build your product in the beginning with vibe checks and iterate as much as you can to make sure the product that you're building works for you and it makes sense before you get into any kind of measuring of anything, because you need to figure out what you want to build first. After you figure out what to build, then if now you can try to optimize it. And when you try to optimize it, that's when evals come in handy, because at some point it's going to be really difficult for you just to rely on vibe checks. You're going to feel like you're guessing because you're going to be tweaking the prompt and you're going to be wondering, I wonder if this is breaking anything else, or the surface area of what you're building is going to be way too large. And you want some kind of measurements and some kind of signal. Kind of like in software engineering, it would be really difficult, honestly, to write software without tests. You would constantly break things and kind of be walking on eggshells all the time. It would be almost impossible to be honest. Like, I think every software engineer can attest to unit tests saving them constantly. And so you wouldn't want to do that. And similarly, you probably don't want to do that at some point in your AI product as well. There are some tweaks though. It's not just like unit tests. So one trap that people fall into is they take their software engineering mindset directly into AI engineering and try to map it completely in parallel and say, okay, I'm going to write some tests for my AI, and that's evals. And that idea is very appealing, but it doesn't work. And so the way that people try to map that over is they try to use off the shelf evals, like hallucination score, toxicity score, coherence score, whatever you want. They'll go to a vendor, they'll go to a tool of some kind. Because that's how, as software engineers, we think about tools a lot of times. And it is appealing to think that, okay, like a tool is just going to solve the problem, this evals problem. Let me use some framework. Um, and so what happens is people use those tools and they get these quote evals, which are some, kind of stock metrics that tell you things about your application that you might want to know, like hallucination score. It sounds like something you might want to know about, right? It sounds like it's like, oh, I want to know if there's hallucination. It sounds really appealing. The sales pitch is really appealing. The reality is it doesn't work, and it's because these off the shelf metrics usually don't correlate to what you should be focusing on. They don't correlate to like the actual problems in your application that are the highest priority. And so what we teach is, hey, you should do some data analysis of your application first to figure out like where your problems even are before you write evals. You should be motivated. Like, so evals shouldn't be an academic exercise. It should be, you should be building evals in service of a problem you're trying to solve, like a real bug or a real issue in your application that you need to wrestle with. And so when I say wrestle with is, so evals aren't free. You have to create them. And there's a spectrum of evals. There's the cheap evals, which are just assertions and you can just write them with code without necessarily calling in an LLM to judge an output. And then there's the more expensive kind, the LLM as a judge, where you have to call an LLM. And the LLM as a judge, because you have to call an LLM, you kind of have to do a meta eval of it to judge the judge. And that takes time and effort. So there's a spectrum. And so you have a budget of time that you can spend on anything in life. And so you need to kind of reason about your evals and say, okay, I'm going to have a suite of evals that are going to, I want these evals to provide me with value. So the way that evals provide you with value is if you need to iterate on a problem over and over again, and you're constantly getting signal from the eval, that eval is providing you a lot of value. It's giving you something to hill climb and something to iterate against. If a problem is like super easy, let's say, you omitted something from your prompt that's like super obvious, or there's a there's a bug in your code base that's super obvious. That should just be a unit test instead. It doesn't need some kind of like necessarily eval. Then do that and just fix your AI system. You might not need an eval. And so it's kind of this data centric thinking, and this is kind of similar thinking that we've had in machine learning and data science. If you're building a model of any kind, you want tests like this, but you have to be thoughtful about these tests, and that's what evals are. So I think that that's one thing I want to get out of the way, because a lot of people may have tried evals or have this misconception of evals. I think a lot of people have done evals incorrectly and been burned by them because they've done them wrong or have done a lot of effort without any payoff to them. And the way that you avoid these problems is doing some data analysis up front, followed by creating these evals. So, yeah, that's just a long-winded sort of explanation of what are evals.
No, that's super helpful. Because it sounds like you kind of need a system to like you need a system in place to start iterating on top of and to start evaluating. So it's not necessarily what you're going to be doing on day one, like building evals while you're building your system from scratch. It's really helpful when you have like the prototype or the MVP or an existing AI product in place that you want to start improving in this systematic way because you know if you haven't even built anything, how can you know what's wrong with your system? You haven't even put it out into the wild to allow failures and mistakes to come up. So I think that that's probably one thing people don't realize. And then the kind of off the shelf evals, it sounds like it's more of like checking a box as opposed to actually trying to solve a specific problem. So kind of changing your perspective to okay, what's wrong with our system, and then how can we create a test that measures that failure or that the error in the system. So I feel like creating that measurement is relatively straightforward for a concrete task. Like if it's a math problem or there's a correct answer, you can evaluate whether the system got it right or wrong, and then you can have some kind of score. But for most things we want to use LLMs for, they feel more open ended. It's like write me a LinkedIn post or you know analyze this legal document. For certain things, there's like a whole range of use cases that might come up that can look different, and the correct answer can have a lot of different forms. There's a lot of flexibility in what's correct and what's incorrect. So how do we develop evals for these kinds of tasks?
Yeah. So because the surface area is so large, and by the way, evals for foundation models are different than evals for applied applications. So for foundation models, evals that you'll commonly see on social media or otherwise are kind of the general purpose benchmarks, which try to measure an LLM's general knowledge across a lot of different tasks. Those benchmarks are of almost no use to you if you're building an AI application. They are useful for the labs, but they're not going to help you. And hopefully, what you're doing is building a bit more scoped product that's not just Chat GPT, doing kind of like a general thing. Because you would have to use a different approach for that. But if you're building a
Well,
scoped thing, oh,
I have
sorry,
a quick question on
yeah,
that.
yeah,
It was really interesting. You said like the benchmarks are not helpful at all, and this is funny because I feel like a lot of people have reached out to me, whether they're a leader at some company or they've run some kind of consulting firm, and they want to know what model should I use? What's the best model? And then I don't know. I'm curious to hear your take on like making that decision. If people trying to build applications, if the benchmarks are helpful in any way, in any capacity, and if they are, like, to what extent.
yeah. I mean, I think the benchmarks are helpful in a meta sense of knowing which models are at the frontier and maybe understanding roughly, not exactly, but just roughly the latency performance trade off. Because that's really the two quantities that you're trading off here when you're talking about AI, um, when you're trying to select models. And so you're trying to kind of reason about that. And there's a Pareto frontier of, okay, if you were to plot the latency performance trade-off of these different models, there would be a frontier of which like there's an optimal selection based upon what kind of latency you're looking for. And oftentimes people don't really have a latency, a strict latency cutoff. They maybe have a fuzzy one. There's something like that. And so when people are asking you what model should I choose, um, really what you want to try to zone in on is like, okay, what's on the Pareto frontier here. And there's definitely some other non-benchmark related considerations like, okay, what cloud are you on? What stack do you have? What are your existing vendor relationships? Do you already have any relationship with Google or Amazon or something like that? Um, do you need to self-host the model? Most people don't. but some very few rare people do want to do that, and they need to use a different kind of model. But largely speaking, I would say most people care about capabilities. And just, it's good to start with the most powerful model you can and then back off. And so I would say, um, people should try the models at the frontier
Yeah.
and
Okay.
just try a few of them.
So it's kind of a few different dimensions. Like number one is performance, like that's what people usually care about. Then it's probably latency. Then it's existing tech stack, and then sometimes if it has to be self-hosted or you're fine with doing cloud. Those are kind of like the main decision points when it comes to picking the right model.
Yeah. And I
Okay.
would say the question itself is a smell. If I met you at a coffee shop and I asked you, or you asked me, or I asked you, or really anything, hey, what model should I be used for XYZ? You would wonder a little bit. You're like, is Hamel using the models? Why is he asking me this? Like, why are you asked? It would have to be a nuanced conversation. Like, you would have to say, well, like I've been using, Claude for this. I started to use, GPT-5 for coding instead. Thought it's kind of like it seems better to me. What's your experience? That's a different conversation. But you're just coming out of the blue, like, what model should I use for X? It is a smell that you're not using them, I think. But what do you
No,
think?
I mean it makes sense. It kind of feels. I mean, typically the question will come from someone who's not coding. They're pretty far away from the code. They're just trying to make these high level decisions. To tell their engineering team like, okay, you got to go in this direction or something like that. Um, but I feel like it's.
Do you think
Um,
those people are using it for non-coding tasks sufficiently?
oh, I see what you're saying. Like actually using
Yeah, yeah.
like ChatGPT to like, yeah. Yeah, I don't know. I usually I guess I try to start from a place of like curiosity of
Yeah.
like, and then I'll probably kind of lean toward like what you're saying. It's like, okay, well, what kind of, like what kind of latency you need? What's your existing stack? Do you need to be open source? And then generally I tell people just use like the biggest and best model, like, GPT-5 or whatever. Actually switched to GPT-4 for an app I'm building because GPT-5 was a little unpredictable. It kind of thinks when it wants to think, and that's not something I wanted. So that was kind of like a nuanced reason why I didn't use GPT-5.
I
But
think that's
yeah,
good. I mean, it's not about belittling anyone. It's more like I try to encourage people to use models because it's really hard to recommend
explain.
models
Yeah, exactly.
without evals. Like if you need a little
Right.
bit of vibe check on it too
For
yourself.
sure.
And I don't like infusing people with my vibe check. I really want try to encourage them. Okay,
Right.
like how do you get your own little bit of vibe check in there?
Yeah, and also it's, you have your experience and your intuition for the problem sets that in the tasks that you do, and theirs might be different, and the models might behave completely differently in those contexts. Like you really don't know unless you try it. Yeah, and I feel like that's like a mindset that's very natural to, like in data science and like people coming from like a experimental background. It's like, okay, let's just try it and see what happens. Like this kind of exploratory mindset. But I feel like, that's kind of hard to sell in business sometimes because people want concrete answers. Like, what's the best? Like, what's going to work? But in a lot of times in machine learning, you're working with these stochastic systems. Um, you have to run experiments on those specific use cases, which I think kind of presents some unique challenges. I know. How do you handle that, and how do you think about that?
One thing I was thinking about when you mentioned this model selection question is that in the evals course, one of the most popular questions that we get are around, hey, how do we test new models? Or I want to use these evals, and the first thing that I want to test are new models. It's like the top thing on people's minds. And we tell people you probably shouldn't be thinking about a new model as the first thing. You should be first of all, you should try to use a frontier model. If you are using a frontier model, it's very likely that you're going to get you should try iterating on your prompt first and look at your system first and see like what is the problem. And I wouldn't, and people just try to keep everything fixed and try new models. Um, but switching models and switching tools, and people do this with like vector databases too, like, oh, the retrieval is not working, let me just migrate to new vector database. Um, so you really have to diagnose what it is that is lacking, and then see, okay, like what is it doing? Like, is the model failing to generalize? Is it not following instructions, so on and so forth? Okay, then maybe you should think about that. But like, it's usually not the first thing on my list, which is surprising because a lot of people, they act, we have like a lot of debate with back and forth on that and explain that.
Well, this kind of sounds like you're, you know, this mindset of identifying the problem as opposed to just like, let me throw a technology at it. So like that's kind of like what people are doing when trying to take an off the shelf eval, or they're trying to, insert a new model or use a specific vector database or specific embedding model. They're like, oh, this is newer, this is better. So let me just use this and then my system will get better. But generally that's not going to work because every system is unique, and you really have to diagnose what's wrong with the product or the app in order to actually improve it. And that kind of seems central to this whole approach to evals that you guys are talking about.
Yeah, I mean, a lot of people want to push a button and say, okay, just automate this for me,
Hmm.
which is reasonable, in let's say reasonable thing to want. I mean, I want that
Right.
too. Um, and it seems like maybe on a surface level, it could be possible. I mean, after all, we have AI, so why can't just AI do it? AI is automating other things. Why can't it automate this eval process? The problem is that ultimately you have to infuse your taste and judgment into the AI. Otherwise, like, what are you building? Like, you have to, transfer your sense, your judgment into the AI iteratively. And so, as of right now, the AI can't read your mind. You have to explain in English what you want to do. And so, the only way to really do that is to iterate and look at some data and respond to what is happening, and iteratively make your product better and measure it. So um, yeah, until we have AGI, you will have to do evals by looking at data. It doesn't mean you have to look at all the data. It doesn't mean you have to drown in data. It doesn't have to be a significant effort, but you do have to do a little bit of it.
Yeah, so this is an interesting point. So how do we make this transition of we're looking at data, we're doing this analysis, we've identified where the system is failing. How do we transition into actually building tests and evaluations for those specific failures so we can improve them?
Yeah. So there's a very specific way to look at data. We say look at data, but it requires a little bit of data literacy to do it. And you can just start with counting. And what I mean by that is you can look at your traces. Um, you can create. You could write. So the simplest approach, and the one that we teach for people starting out, is called error analysis, where you go through and you take notes on your traces at the trace level. And what I mean by taking notes is if you find something that has gone wrong, you don't try to root cause it. You just journal about what's not ideal about the user experience, and you just write that down. And you do that for, let's say, 100 traces or so, and then you categorize the different types of issues that you find. So you can categorize those notes, and you can use AI to help you if you want. Categorize those notes, and you can count them. You can count how many times a specific genre of issue um, occurs. Now, there's a little bit of art to it, and you can. It sounds. I mean, you can get really good at it in terms of like creating the right categories and like being really good at writing notes and knowing when to stop and knowing when to move on. All these things can make it like very fast. But even a simple data analysis like that will show you what your problems are. So let's say your problem is, hey, your AI is not handing off to a human. It's not escalating to a human when it should, when something is going wrong. And you want to write a test for that. So some tests you can write very easily. You don't need to call an LLM. Let's say, for example, um, you're emitting a user ID in the answer where you don't want to. Let's say it's taking the user ID that's said like in the system prompt and it's putting it in an answer. So you can probably check that with code. You don't need to have an LLM as a judge. You can, use regex or something like that to say, okay, then the user ID is appearing in the AI message response, and you can check for that. Something like handoff, that's a little bit more subjective. It's going to be hard to test that with just purely code. You can do some analysis on it to see. I mean, so there's a middle ground. Like sometimes you can do clever things like find keywords that, but for the handoff problem, yeah, that's a good LLM as a judge problem. And so, you want to use an AI to help you identify cases of failures. Now, what you want to do is, so you have to be really careful when you do LLM as a judge. The first question that comes up when you use an LLM as a judge is like, okay, it sounds weird, right? Using another LLM to judge your LLM. So it's like turtles all the way down. Like, how do you know if any of this is right? You know, um, like, why is it okay to have another LLM judge your AI? What if the AI is just wrong? How do you know? So that's what we teach. It's like, okay, you have some labels. You have some human labels. Like, hopefully you trust yourself. If you don't even trust yourself, then it's not worth, you have to stop. But like, okay, you trust yourself, you trust your judgment, you have some labels of like, hey, when does this particular failure happen? And you can curate those into a test cases, and you can measure your LLM judge against your human label data, and you can measure the alignment between the human and the judge, and you can measure scientifically how good your judge is. And it's usually worth it's not usually, it's always worth doing this exercise, because your first crack at a judge is not often not going to go well. um, and you'll find that you're missing certain edge cases or whatever. You want to iterate at least 3 or 4 times on it to make the judge good, and just measure the alignment again between you and the human until you're satisfied that's like aligned enough. And so that's the key. That's one of the key things people are missing, is like, hey, you need to align the judge. Don't just prompt and pray, because you can prompt and pray in your product, but you can also prompt and pray in the eval. I mean, you don't want to, do that. So that's the key thing you want to keep in mind. And there's a lot of nuances like how to do that correctly. You want, just like machine learning and data science, you want to split your data up. The splits are a little bit different percentages, maybe because you're not actually training a model, you're just using some examples in your prompt. But the same thing applies. You don't want to overfit your LM as a judge. You want to make sure that it's generalizing to unseen data, or and so you use the same kind of similar principles of machine learning to figure that out. So it doesn't have to be painful. It sounds painful, like, okay, you have to do all of these things, but you can get really good at it with a little bit of practice. But yeah, that's basically, those are the kind of two kinds of evals: is like code based, assertion based, and the LM as a judge. And then now that when you have these different evaluations, now you can run them. And you can run cheap ones in CI, like on every commit. You can run more expensive ones like nightly, and you can also run them against production traces every so often. So what you want to do is, on a regular cadence, you want to continue doing this error analysis, but you want to, over time, start sampling your data more effectively. So, some random sampling, some samples pulled from production traces that are failing your evals, so you can take a look. And then also there's other ways of like computing some statistics over your production traces to find anomalies you know, like for example, what if there's like so many uh, too many turns, like some traces might have outside the distribution of like length, number of turns, maybe semantically really weird. You can be really advanced, like how you sample, but this all creates a feedback loop where you're constantly making your evals better and making your system better. But the key part is not the eval. The key part is like you're making your application better. Because like at the end of the day, like no one cares about your evals, and your eval is not going to help you make money, or not. Their evals itself is not going to help make your users and customers happy. Like you want to make your product better. And so to kind of come back to the original point is like you want to make sure like these evals are all pulling their weight, they're all valuable, they're tracking real problems that you're trying to iterate against.
Okay, so the error analysis process, you identify these. Well, basically, you have to look at these traces. So maybe you look at 100 or so, and you just take these open ended notes on what is going wrong and the different failures that you're seeing. And then once you have those notes, you can find the patterns, whether you're using AI to help you cluster them or you just manually kind of mark each as a different failure mode. And then this kind of gives you clues of where you can start improving your system. And then I guess this will create a feedback loop. So if you kind of do 100 traces and you see like 15 out of the 100, you have these handoffs that are going wrong or something. You can go back to your prompt and see, do we talk about when to do handoffs? Like, oh, it's just a tool and a description of how that tool works. We don't really tell it when to do handoffs and how to do it appropriately. So let's add some English here on how to do that effectively, and then we can do the whole eval thing all over again. Um, so yeah, so that's interesting because there are like two ways you could do it. You can just count the failure modes from the manual error analysis, um, or you can create the automated eval, whether it's code based or LLM based, and then you can run that and update the system based on the score that you're seeing there. So like at what point does it make sense to actually start making evals, like actually making automated tests for these things, as opposed to just doing this manual feedback loop of doing the manual labeling, updating the system, and then doing more manual labeling? Like, yeah, so when do you make that transition?
Yeah, so it's really like it's a little bit of an art. So
Yeah, okay.
you have to be driven by improving your product. So the whole point of like when you see error analysis, you'll be presented very quickly with a set of problems, and some of those problems are going to slap you in the face and say, "Oh, like this is a bug. I just need to fix this." You stop everything you do. Stop the evals process because, like, again, the most important thing is improving your product, not the evals. So go fix it. Other errors are going to be a little bit trickier, where maybe it's not an immediate bug, or yeah, like it's not like super obvious how to fix, and you want to iterate a bit, and that's when an eval will help you iterate, so you're not guessing. Um, and you'll gain intuition after doing evals. Let's say doing this cycle 2 or 3 times. You'll get an intuition like how long does it take you to do an eval? What is it like? What does it feel like? And you can kind of get it, do the trade off in your mind, like, okay, should I build an eval to help me iterate on this problem? Like, how big is this problem? How important is it? And is it worth including an eval? Um, and the only reason, again, you create the eval is like you know that it will help you solve the product problem faster. Um, and so you go ahead and create it and you add it to your suite of evals. The last thing you want, by the way, is for your suite of evals to all pass at 100%, because that would mean that your evals aren't doing anything. So you want to be failing some of your evals at all times, because um, you want something to improve upon, you know? And
Right.
so um, you should just be really skeptical if you are, having 100% pass rate on everything.
Right, because the point of the eval is to give you the feedback to improve the system, and if it's at 100%, you're not really getting any feedback, so there's no point in having it. Okay, so that's really interesting. You have to develop this intuition of what's a small problem that I can just fix, versus what's going to be a big important problem that I can't just fix with one small change to the prompt. I'm going to have to iterate over like multiple cycles, feedback
Yeah.
cycles to actually improve this problem because it's like a pretty big thing, and this thing will never be perfect. So it's just I'm just going to shoot for better, not 100%.
Yeah, you'll get an intuition. And there's different kinds of evals. Like I said, like some are a little bit cheaper to create, some are more expensive. Um, and so you balance that in your mind against the severity of the problem and the impact of fixing that problem.
And so I like how you call it cheap versus expensive eval. So you can do like the code based one, and then you can do the LLM as a judge. So this is something I wanted to ask you, like even back during the evals course, but wh- yeah, I'm curious to kind of get your sense. What do you feel is going to be better? Like one silver bullet, as in like one LLM judge that's kind of you put a lot of energy into, or like 100 golden BBs. So it's like a bunch of code based evals, and any one of them isn't going to be super effective at identifying the failure, but there's like 100 of them, and they're super simple. So when you kind of take their average together, it gives you a sense of when that failure is actually occurring. I don't know. Do you kind of have like a sense of like,
Yeah, let me frame it a little bit differently. So you should
okay.
always try to use the cheapest eval to try to address the issue. So one example that I really like is a student in the class, Teresa Torres, one of my favorite students. She created a interview coach AI, and for the interview coach AI, one of the errors was suggesting, and I could be getting this slightly wrong, but the point still holds. Is so one of the questions was, uh, one of the errors was like leading questions, like doing a leading question of some kind. And so leading question, like how do you test for that? It sounds like you need an LM as a judge. It sounds like I don't know, you can like use code to test for that. Now she understood this concept of like use the simplest thing that gets the job done. And so she did a little bit of an analysis. She said, look, there's this is set of keywords that is 95% correlated with leading questions. And I'm just going to test for the keywords because you know what? That's a lot cheaper. It's a lot easier and it gets the job done. So I'm going to do that. That's exactly the right mindset. Is you want to unblock yourself. You want to keep things as simple as possible. You only want to step up to the more expensive level of complexity, really in any kind of engineering, not even AI, unless you need it. And so that's the balance to keep in mind. Is like you want to think, okay, is this thing I want to judge? Is it possible to? Is it reasonable to have a code based eval? Can I think of something? If not, then there's some things that you can only use an LLM judge for.
So it's always worth asking the question, can this be solved with just code? And instead of, even if that means having like 5 code-based evals that are checking for keywords or some like, regular expression thing or word count or whatever it is, um, versus like spending the time and iterating on an LLM judge, which can be very costly.
That's right. Yeah.
So I just want to call out, we will do Q&A. So if you guys have questions, drop them in the chat, whether you're on LinkedIn or YouTube, and then we'll have Hamel answer your questions. But we'll just keep going here. So I guess we're kind of getting into the end, like the more kind of non-technical questions. But I'm curious, like based on all the projects that you've seen, whether you're like helping your clients or helping like seeing what students build or whatever it is, like why do AI products usually fail?
They can fail for a lot of reasons. So you might expect me to say they usually fail because of evals, and that's not my answer actually. Um, there's a lot of different dimensions on which you can fail. Like you can fail for just normal product reasons, like you don't have the right team structure, you don't have the right skill set, you're planning too much, you have too much overhead. Um, I have a number of clients like where they've had, maybe have one engineer against 30 other people who are like planning on what to build, and they have like hundreds of meetings. That's not like an AI specific issue. It's just like you're not going to be able to build any product like that. So there's a lot of general failures of how to build software that where your AI product is victimized accordingly. So I would say that still kills more AI products than any kind of like a inherent AI failure. Um, like that, yeah. It's really like this product thinking, shipping quickly, getting feedback. Um, is why lots of things fail.
So it's not even there's nothing really special about AI products. It's just those who are able to get their product in front of customers, get real feedback, are the ones that are going to be able to, build
It's a
something
little
that.
bit different. Like it's so yeah. Maybe I was going too far by saying it's not like different. What I mean is, um, it's not different. It's not too different than like machine learning either. It's kind of a blend. It's not as extreme as classic machine learning, but you need to do lots of experiments with AI products. It's not about roadmaps, like static roadmaps where you kind of have features you want to ship. You don't know what's going to work in advance necessarily a lot of the time. So you need to take a lot of shots on goal, and you need to organize your team so you can do lots and lots of experiments, and sort of have like an experimentation roadmap rather than a feature roadmap, which is a very hard thing for organizations to like wrap their heads around when it comes to building, because they're used to traditional software. They might be sort of ingrained in their old ways.
Well, I'm really curious about that because I feel like, coming from like a data science background, that feels very natural to me, but also I'm very new to product development, so I have no idea where to start. Like, how do I even build an experimentation framework for kind of testing if the product's any good and people actually want it? I don't know. What do you feel like are the key ingredients to building something like that?
Yeah, I mean, I also have always been a machine learning engineer, a data scientist. So I've always, if I've encountered environments that don't allow me to experiment rapidly, then I just don't work well in those environments. And so I'm not 100% sure how to untangle people, other than telling them not to do that. There are some really good presentations by my friend Brian Bischoff, who has some nice talks on this about capability funnels and roadmaps. He has given a guest talk in my course. It's also on my YouTube, um, of not managing AI products like traditional software. If you Google that, um, Brian Bischoff, he has a really good talk on that. But
Yeah, I
yeah,
think I actually saw that talk. I
okay,
like that funnel, the failure funnel, as you're saying, because like you'll kind of see that there aren't a lot of failures happening, and then at one step there's like a bunch of failures happening, and then so that kind of gives you some clues on okay, so there's probably something going wrong here. Let's dig into it. Um, okay, cool. So we got one question in the chat. Keep them coming. We've got like 15 minutes left. So you guys have any questions on evals, product development? I mean, Hamel is like the evals guy now. So if you guys have any evals questions, uh, and he's probably seen so many different like real AI products, both machine learning in the context of machine learning, but also context of LLM. So any questions are welcome. So this is another kind of like non-technical question, but like, what do you feel like is missing from the current AI development stack? I know, you know, I guess obviously I'm kind of in the back of my mind, I have like evals, like I have evals in the back of my mind, but um, we have the IDEs, we have AI assistants like AMP or Claude Code or whatever, and we have like the vector databases. But what do you think is kind of missing to have this more experimental approach to AI product development?
Yeah, it's really data science for AI. There should be a movement called data science for AI. Maybe you should spearhead it, Shaw.
I'll
But like,
try.
um, really, like part of the narrative of AI engineering has been you don't really need to know any data science at all. You just need to know software engineering and use APIs. And you know, you don't necessarily need to focus on evals or analysis or data science. And that was probably true in the first era of AI engineering because, after all, you do need to create a product before you can optimize anything. And so, like, data science is about optimization. Data scientists are not the greatest at creating products, right? It's like a different skill set. And so, um, I don't think the AI engineering sort of manifesto is wrong in that sense. Like, it was right to focus on more product engineering type of stuff because that's what you need. Like, otherwise, there's no product. That's like the sort of great filter, if you will, in some sense of like, can you even get started? I think like as the whole industry matures, um, you need a lot of the same data tooling and a lot of the same thinking around building AI products, like optimizing them, right? So like we can teach evals, but in the limit, like there's all these things that come up, such as how do you sample data? How do you analyze that data? How do you navigate data efficiently? Um, all the tools around visualization and analysis and whatever, all the statistics. Um, you bring a lot of those tools to bear when looking at your system, and those are really correlated with evals. You can do evals without the full breadth of those, but as you become more sophisticated with evals, as you kind of scale your evals or scale your system, frankly, and you want to get better at it, you're gonna have to bring in like data science skills. That's the only way you can wrangle all of that information and sort through it. And so it's really like what stack is missing. I would say it's about 75% of the data science stack is quote missing and it is interesting. I think maybe I see that data scientists are starting to come on the scene and speak up. The most obvious place to kind of speak up is evals, I think. But I think um, you know even in the more basic things like data analysis, like error analysis seems so dumb. Like I almost feel embarrassed to discuss it, honestly, because like it's kind of so simple. It's like, hey, look at stuff and count them. That's not a skill set. I'm not sure that's a skill set that anyone will find like sexy or because it's accessible to everyone. But that's where we're starting from. We're starting from like, hey, the very basic sort of skills are necessary to be effective. So that's my rant of there should be data science for AI.
No, I like that because the first era it was a lot of 0 to 1 because the tech was so new. It's like, oh, what do we do with this? Just start building a bunch of stuff. So definitely you don't need a lot to get started. You can just use the APIs and just like Python or whatever. But going from 1 to N and building real products that are like legit things that are serving a lot of users, you're going to need to use these data science skills and techniques and the mindset of actually trying to optimize the system so that it actually works well. So we've got some questions coming in the chat, so let's transition to those and then maybe I have like one more question, but if we don't have time for it, it's all good. So Leon So asked, do you see any major differences with respect to evals for vision models versus text models?
There's not too many differences. You still do an error analysis. The error analysis is going to be on different data, and you might need a different set of tools to render the data. Um, but it's the process is the same.
I hit the wrong button. Okay, so basically, the framework is basically the same. It's just maybe you're you're gonna have to evaluate images instead of text or
Yeah, that's right. Yeah.
something like that. Maybe your data viewer looks different or something like that.
Yeah.
Okay, so we got another one from Edgar. How do you think about evals? Are they meant to be used to guide? Are they meant to be used in guide development of AI applications, or are they meant to be for monitoring in production, or both? Also, if meant to be used in production, how to use their output as meta evals? So I feel like there's a lot in this question here.
Yeah. So there's a lot in here. First of all, uh, it's somewhat used as a guide of development, but I want to be careful with that because there's this concept in software engineering called test-driven development, and I would say you don't want to do eval-driven development, which means you don't want to build your evals first before developing your software. I don't think that's the right approach. It's okay to have some evals if you prospectively know that your application needs to do XYZ thing and you're very confident. But most of the time, I would try to validate what errors are actually happening and prioritize those because there's like a lot of surface area here, and you don't want to get burned. You can get burned really easy by evals by overcooking it. So that's, and then the other question about use for, yes, so the whole purpose of evals is to also in addition to offline tests in CI/CD and so on and so forth, you want to use the same evals for production monitoring um, and for data exploration as well, like help you filter interesting traces to look at. Um, and there's this concept called guardrails. Guardrails are special kind of eval that sits in the critical path to the in between the LM call and the response to the user that can block the response to the user based upon certain errors that occur and like either block it completely or trigger a retry. And there's a cost benefit of having an eval in the critical path because it might increase the latency, it might increase the cost. Usually people don't put like really expensive LLM judges as guardrails. And you have to you have to reason through what should be a guardrail and what should not be a guardrail. There's some writing about that. I have an FAQ. You can Google LLM eval FAQ, and one of the FAQs are what are talking about these guardrails. So I encourage you to take a look at that.
So yeah, I like the kind of two uses of evals, like talking about that. Like you can use it to improve your system, even though you want to build your system first, so you can identify failures, and then you can use it as like this feedback loop. But mainly, you want to use it for monitoring, so you kind of have a sense of what's actually happening in the real world with users using it, and you can use it to grab traces and you have like the manual review and kind of have it feels like you're repeating error analysis in a sense, but like on a specific sample of the traces. Okay, so let's go to the next one. What are your thoughts on evals for ASR to TTPS pipelines, conversational agents?
So what's ASR? Do you know?
I'm not sure. Let's see.
Let me use
Agent.
ChatGPT because I don't know. I don't know what this means. I don't know what ASR means.
I'm gonna guess artificial site reliability. That's my guess. What's your guess? And before we ask ChatGPT, what's your guess?
So TTS is text to speech.
Okay.
So I don't know what. Okay, speech
Speech
recognition.
recognition, automated speech
Automated
recognition.
speech recognition.
Yeah, maybe.
Um, uh, I don't know what this means. Text to speech evals.
So
I
maybe it's
guess
like
like
evaluating, yeah, audio, like audio inputs. So maybe similar to like the vision model, text model. So maybe it's like a audio model or something like that.
yeah. So the ASR case like is interesting. Like if you're just trying to evaluate transcription or text to speech, I guess. Um, I haven't actually thought about that. Like the speech, so getting speech as output. Um, I would certainly start with error analysis again, but there might be ways of, if it's the audio as an output and you have text as an input. Um, Honestly, I don't know. Like I haven't worked on that problem. I would have to look into that specific problem more because I suspect there's something interesting there in terms of metrics, and it's a scoped. So anytime you scope like that's a pretty narrowly scoped problem of like, hey, I'm trying to go from uh, text to speech or speech to text, and you want to measure how good that is. There's probably you you probably want to use a special set of techniques to evaluate that. Kind of like how retrieval is a very scoped problem relative to the whole, like, you know, like measuring how well your AI is doing. So like, with retrieval, there's a very specific set of analytical techniques to help you diagnose like if your retrieval is working correctly, that draw on the fields of information retrieval. For this, like, yeah, there's probably something there, as well, because it's very narrow. So like when you get this narrow, then I would I wouldn't necessarily only lead on the general purpose approach that we discussed.
Yeah. So with text to speech, that's going to be its own module, kind of how retrieval is its own module in your AI system. So you can, have specific evaluations and their specific techniques for improving that part of the system.
Yeah.
Okay. So I feel like we're right on time. We got 1 minute left. So, with that, Hamel, thank you so much for joining and sharing all your expertise on evals and experience. Thank you guys for the questions. So, Hamel has his upcoming cohort of the evals course, which I highly recommend. I was lucky enough to be in the first cohort. Um, but Hamel, where can people keep up with you? Kind of learn about things that you're doing. Where's the best place?
Yeah. So the evals course, by the way, there's a discount for listeners of this podcast. If you go to evals.info, it's 35% off the course, which is like a lot off the course. It's like, $1,300 off the course or something. Um, so you can find the course there. My personal website is at hamel.dev. And those are the two ways to find me.
All right, perfect. Easy. All right, guys. Thank you guys for joining, and we'll see you in the next one.
Thank
Take
you.
care.
See you.